Chapter 10, Lesson 2, Graph y equals ax squared plus bx plus c. So we're going to get a little bit more complicated now. Previously we just went ahead and we did y is equal to ax squared plus c. Now we're going to add this bx term and see what happens when we deal with that. So a couple of things here are important. The a term here, let's just review at this point. The a term here, that determines whether the graph, the quadratic function opens up or down. If it's greater than 0, then it opens up. If it's less than 0, it opens down. So if it's a negative number in front of the x squared, it goes down. If it's a positive number, it goes up. It is narrower than this base function, the most important one, because that's what we compare everything to. It's like when we compared y is equal to x for a line. If the value of a, again here, is greater than, the absolute value of that is greater than 1, then it's going to be a narrow one. So if you imagine this being y equals x squared, then if a is, the absolute value of a is greater than 1, then it's going to be narrower. It might look like that. And if the absolute value of a is less than 1, then it's going to be wider. So if we reverse it, it might look like this. So that's important to understand. There's also something called an axis of symmetry on these. And the axis of symmetry is going to be, that is the line where if you fold it over that they match up. So x is going to be equal to negative b over 2a. And the vertex, that's that point right there. That's that point right there, that point there, that point there. That's the vertex. And that's actually going to be this coordinate for the x value, and then the y coordinate that actually corresponds with that. And there's always going to be a y-intercept at c. So wherever this is, when x is equal to 0, y is equal to that value, because these two cancel out. So that makes sense. So let's look at a couple of things here just to see what all this means, because I know that was a lot. So for each function, we're going to identify a, b, c, and then negative b over 2a. So a in this case is going to be 1, b is going to be negative 4, c is going to be 2. And then the value of negative b over 2a, negative b is going to be 4 over 2a, that's going to be 2. That's going to be 2. So what that means is, that is, again, when x's value is that, when x is equal to 2, that's going to give me that line of symmetry. That's why it's right there. And that's the vertex also of the parabola, where it crosses through there. So if we wanted to find out the value of y, we would just plug in x is equal to 2. Into this equation here. And then we end up with y is equal to 4 minus 8 plus 2. So y is going to be equal to negative 2, which is exactly where that point is right there. So it's 2, negative 2. So that makes sense. Let's try a couple more here. So in this case here, a's value is negative 3, b's value is 6, c's value is negative 1. So negative b over 2a, negative b is going to be negative 6 over 2 times a. 2 times a is going to be negative 6 again. So a's value, so that value is just going to be 1. So that's why your line of symmetry is right here when x's value is 1. And that makes sense. If you look, again, where it crosses here, there is a y-intercept right at this point right here. That is where it crosses the actual y-axis. So that's 0, -1 is going to be a point there. And then if we wanted to plug this back into the equation to get our point for that vertex, it would be -3 times 1 squared plus 6 times 1 minus 1. So that's going to be, y is going to be equal to -3 plus 6 minus 1. And that's just going to be equal to +2. So that's why our point right there is going to be 1, 2. And that's what it is right there. So I'm just going to now just cover these a little bit more quickly because I want to get through a couple of other things here. So this is 1/2. This is 4. This is 11. So the value of -b is going to be -4 over 2 times a, so that's just going to be 1. So it's going to be -4 is going to be that value. So that's why, again, we got that line symmetry is going to be x is equal to -4. So that makes perfect sense. So now, if we plug that in, we would see that see what the point is going to be. It looks like the point is going to be -4, and then 1, 2, 3, 4, -4, 4. That's what it looks like to me. Don't know for sure. I'm not going to do that one this time. But the important thing is right here. Check that out. We got it crossing right there at 0, 11 because of that c term. So one more here. -1/4. -1, -3. So the value of this is going to be value of -b squared. So that's going to be 1 because negative, negative. And that's going to be 2 times that. So that's going to be 1/2. So -1/2. So that's going to be equal to 2. Actually, it's going to be equal to -2. I forgot the negative there for a second there. So -2 is going to be my line of symmetry right there. That makes perfect sense. And if you look again, that term there, right there, I could find the y value by plugging in -2 into this equation again, but I'm not going to do that because I already did that a couple of times to show you. So when it says choose the correct word to complete the statements, the graph of y equals ax squared plus bx plus c, it opens up or down if a is positive. It opens up if a is positive, and opens down if a is negative. It is narrower or wider than the graph y equals x squared if a, absolute value of a is greater than 1. It is actually narrower, and that's wider in the other case. So we're going to move on quickly here, because I know that's a lot of vocab. What's the relationship between the y-intercept and c? Well, that is going to be the y-intercept. It's 0, and whatever the value of c is. What's the relationship between the x-coordinate and the vertex and that? Well, that is going to be the x-coordinate and the vertex, and this is going to be the line of symmetry. So it says here, consider the function of y equals 3x squared plus 12x minus 8. Find the axis of symmetry of the graph of the function. Find the vertex of the graph of the function. So what we're just going to do is A's value is going to be 3. B's value is going to be 12. C's value, it's not really all that relevant here. It's going to be -8. So actually we don't even need to worry about this. So I'm just going to cross that off. It's going to be -b over 2a, if you remember that. -b, so -12 over 2a. So the actual line of symmetry is going to be -2 is equal to x. Then when we plug this into the original equation, we're going to come up with y is equal to 3 times -2 squared plus 12 times -2 minus 8. So let's see what that's going to be. It's going to be y is equal to, it's going to be 4, it's going to be 12 plus -24 minus 8. So y is going to be equal to, let's see here, this is going to be 12 minus 24, that's going to be -12, -12 minus 8, so -20. So the actual point should be -2, -20. That's where the actual point should be for this graph. That's going to be the actual vertex of the parabola. And that's all we have time for today. Graphing this is just to find out probably the easiest thing is to find out that line, that vertex point, and then go from there on either side. So the vertex point, and this one's going to be, again, -8, so it's going to be 8 over 2a, so that's 4. So 2 is going to be our vertex point, or our line of symmetry, so x is going to be 2. And then I'm going to find out my y-coordinate based on that, and then I'm going to start applying on either side and know that there's symmetry based on that.